Good evening to all. Am I audible? Hello. Am I audible? Okay. Just we'll wait 1 or 2 minutes. Then we'll start. So today we will be learning about the routine and type tests are to be done on a motor. So actually this course content is made such a way that from the because I have not kept in detailed design of machine and the inverter in this course, but here I will be covering the entire from selection of the machine, from selection of the power electronics, its control, and till its successful operation. So I am requesting all the people, mainly to the student, please try to learn the concept so that by your own you can implement or make it. When some people, when you will be in industry, say you got one project that you have to make the complete speed control of a flow loop, or you have to make the speed control of a electric vehicle, or this kind of thing, so that you can do it by your own. So at the end, a few lectures during the end, means the last 2 to 3 days, I'll be telling about the pure about the connection with the drive and the machines, induction motor drive with motor and its control, commercial drive which are available in the market, how to select that, how to, already we have understand the selection of machine, and BLDC drive, what are the commercial BLDC drives are available in the market, and how to integrate with the machine and to operate the machine for the intended purpose. Anyway, I understood it is true that a certificate is needed, but you remember, certificate is a necessary condition for a professional, okay, but the sufficient condition is you have to learn it. Even though you have lots of, I have seen people having lot of certificates, they have very good academic records, but when you are going to industry, you remember, you are a professional, you have to perform. You may get 100 out of 100, but there is a project, you have to say, there is a project, you have to speed control, you have to do the speed control of a vehicle. You are good in academics, you got 100 out of 100, but practically you are not able to do, so there is no use. So certificate also needed, as I told, it's a necessary condition, but the sufficient condition is to learn and perform. So that also you please remember in your mind. This course course content I have made so that you can perform the thing by your own. So already last two lectures we have learned about the very basics of induction motor and the selection of induction motor and its speed torque characteristics. So basically, to why speed torque characteristics are required, because without that you cannot if I don't know the accelerating characteristics of the machine, it may not able to produce the I cannot select the machine for the desired purpose, or it will not able to cater that. You know, when any induction motor will be used in a vehicle, there is a requirement of the braking torque. This vehicle should able to reach this speed within this much second. All these things, when you are going to so these questions you can ask Pantech. I am only teaching you, but these are all things are decided by Pantech only. I am not the right person to answer all these questions. So this when we want to decide the braking torque and all, so your speed torque characteristics are very much needed. So already we have learned it. Okay, now say we have arrived the rating of the machine and all these things, and we have given the details to the manufacturer. They have manufactured. Now we have to take it to our factory for final integration. So before that, some of the tests are to be performed as per the standards. So we are Indian, so we will be following Indian standard. Okay, so based on the standard, some of the tests are to be performed prior to accept the machine and to dispatch at site. Okay, so what are those tests? We will be discussing that things today. It's a very important thing, but I'll request all of you to follow me carefully. It's not difficult, but please try to follow me. So as I told, we will be discussing about the tests which are to be performed on the machine prior to accept it or to dispatch it at site. So they are broadly classified. They are mainly classified to routine and type test. So what is routine test? So it is, say I have given a bulk order of 100 BLDC machine or 100 induction machine. So these tests will be conducted on each product. That means on the 100 product, 100 machine, I have to perform these tests. Okay, for all the machine, for all the 100 machines, I have to perform these tests. Even though they are same type, the ratings are same, everything is same, but we have to conduct the routine test on each and every unit before its acceptance. So that is called routine tests. What is type test? Type test is, it will be conducted on one machine from each type. Say one machine is 10 kilowatt, one machine is 100 kilowatt. So this 10 kilowatt machine is, say, I have ordered 50 numbers. 100 kilowatt machine, I ordered 10 numbers. Routine test, it will be conducted on 50 and 110 numbers, but the type test, it will be done only one number. And few of the tests are normally, that is the understanding between the manufacturer and the purchasers. Sometimes some type tests are destructive type. That means it may deteriorate the life of the machine. So sometimes the type tested machines are not accepted. It is just to keep as a spares, not spares or something for experimental purpose, but that depends. So type test will be conducted on the prototype of the product, means each type to confirm the design specification, like your temperature rise test, full load test, and all these things. Those are the type test. Now, what are the routine tests will be naturally performed for the induction machine. So first is IR test, which is called insulation resistance. You know what is called insulation? Insulation means this will restrict the flow of it will give some restriction to flow the leakage current. Okay, so these are this is a separate subject that I am not discussing today. So the current, the total current flowing through the insulation is sum of four components. One is conductive current, another is called displacement current, another is called polarization current, another is called surface leakage current. So this total summation of these four currents are called leakage current. And say you have applied the voltage V and your leakage current you obtained I. So this is your insulation resistance. Basically this will give the healthiness of your insulation system of the machine. Winding resistance, that will come from your design specification, because this winding resistance will determine the torque, so many electrical and mechanical parameters. Then you need to do the no load test. As I told, it's a routine test, so it is to be done on each and every machine. So no load means your motor shaft will be not coupled with any load, and we have to see the condition of the machine. I'll discuss each test individually and its procedure and its acceptance criteria. The lock rotor test, that means you have to lock the rotor. Already we learned that if you lock the rotor, then the entire machine will work as a short circuit. So very quickly it will start to draw the rated current. If you lock the rotor by some arrangement, and if you apply the voltage, say motor rated voltage is 415 and its full load current is 50 ampere. Now if you lock the rotor and using a variable transformer, that means what is called that auto transformer, if you increase the voltage from 0, say within 60 volt, it will start to draw that 50 ampere. So why it is required, I will tell you. So this is called the lock rotor test. Then the reduced voltage running up test. Reduced voltage running up test means we have to reduce the voltage and we have to run the machine. Okay, and we have to find out is there any abnormality. The open circuit voltage ratio for stator and rotor both, but I am not discussing these things because this is applicable for slip ring machine. I am not discussing it here. Then the high voltage test. This is a dielectric test. This is also, it will predict the insulation quality of the machine. Now the first thing, the insulation resistance test. So the rated voltage up to 660 volt. If your machine rated 660 volt, the insulation tester, the test voltage should be 500 volt DC. And above 660 and up to 1.1 kV, that you can use 1000 volt. Or for the higher value, if it is system is 6.6 kV, if my machine is 6.6 kV, normally I used 5 kV mega. So those are the things. Not this standard is IS 325, you remember, Indian standard. I'll write this side, Indian standard 325. Okay, now what should be the acceptance criteria? The minimum insulation resistance should be kV plus 1. Say my motor rating is 6.6 kV. So 6.6 kV plus 1, that means 7.6 mega ohm. This is the minimum acceptance criteria. So now you have understood what is insulation resistance test and how to do that insulation resistance. So that is called, normally it's called Megger, MEGGER. It's the name of the company, but people used to tell that one because that insulation tester is first made by this company Megger. It is from UK Dover. So how to test that insulation resistance? You take any, say there is a conductor. This is a conductor, it is insulated. This is insulated like this. This is the insulation. Here you apply the positive lead of the Megger, and in the conductor you apply the negative lead of the Megger, and you apply the 5 kV. Say my test voltage is 5 kV. The device will measure the leakage current and it will divide it by the applied voltage and it will estimate the insulation resistance. So same way we can perform for stator winding and all. And in that case the acceptance criteria is this. If the machine is rated for 6.6 kV, so 6.6 kV plus 1, which is 7.6 mega ohm. So minimum insulation resistance should come 7.6 mega ohm. Now the winding resistance. For winding resistance, simply you have to follow the data sheet, because no standard will tell about the acceptance criteria of that, because this is depend on your electrical and just 1 minute. Sorry. So the winding resistance, basically the winding resistance will be checked based on the data sheet of the machine, because it will define the it will predict the performance characteristics of the machine. So no standard will define that. Next is the no load test. No load test, as I was telling, the motor shaft will be decoupled. The machine will be allowed to rotate without any load. Okay, so the motor shall be run at rated voltage and frequency given on the rating plate. The motor shall run to its normal speed and shall not show any abnormal electrical or mechanical noise, and that time you have to monitor the power, current and speed, okay, which will be required for the determination of no load loss, and this will be needed to calculate the efficiency of the machine. Okay, now coming to locked rotor test. So say this is the machine, and it will be rotating like this. So here you can use, normally people will use, I'll draw this side. Say this is the motor, this is the shaft. So normally here normally people will clamp it like this, will bolt. Okay, the rotor shaft will be clamped, and this is your power supply. This will be given through a auto transformer. Okay, now say the motor rated voltage is VR and the motor rated current is IR. Okay, now if I do this and slowly I start to increase the voltage from 0, say at V capital R, which is much lesser than VR, the machine will start to draw the rated current. Okay, so when the motor will be fully loaded, actually that time it will draw the current IR. But if I force by externally, if I lock the rotor and apply the voltage, then with a voltage of V capital R, it will start to draw the rated current as it is shorted. So I have to find out that voltage. Now if I divide by this, you will get some factor. So this is the factor of the inrush current. It's a thumb rule. Normally it is more elaborated in, it is more it is more elaborated in JEC 37. Even though it is a linear, here I have shown that it's linear relationship, but actually it is slightly non-linear. So that things is clearly elaborated in JEC 37. Okay, it is elaborated in JEC 37. But as a thumb rule, you can find the inrush current using this method, and for that this lock rotor test is important. Reduced voltage running up test. So this test will be done up to the motor rating of 37 kilowatt. Above 37 kilowatt, these tests are not done. So normally 1 by root 3 times of the rated voltage it will be applied, and for each direction, if it is a bidirectional motor, it will be rotated for both the direction. If it is a unidirectional motor, it will be done for that direction, and we have to see a abnormality of the machine. Okay, so this is called the reduced voltage running up test. So these are the things, as I told, when you will be working in industry, you can see, you can refer this standard IS 325. All these things will be mentioned in details. Okay. Now the HV test, high voltage test, the dielectric test, as I was telling. So here, how much voltage is to be applied? This is AC, okay, which is a destructive test. Any problem in the insulation, it will burn. So you should be very careful. So here is the table. So normally we will follow 2 into rated voltage plus 1, that much kV. And this will be applied for 1 minute. Say my motor voltage is 415. So 415 into 2. So that is 830. So 1.83 kilovolt will be applied for 1 minute, and there should not be any leakage. If there is a more leakage, normally in high voltage testers having its setting that it will automatically trip the power supply. It will not inject further voltage. Okay. So this is called the high voltage test. Okay. So normally this is done on normally it is done on the stator winding. Okay. Now coming to the type test. So in addition to the type test includes all the routine tests, and in addition to that, these are the extra tests are to be carried out. Okay, the dimension, you cannot make your motor as per your own, because you should follow some standard. The full load test, you have to load the machine, you have to check the temperature rise, your cooling, as I was telling, your cooling should be sufficient enough. It should not the temperature should not shoot up. The momentary overload, suddenly some overload came, your machine should not stall, it should capable to take the transient. The vibration and noise, that is a in high speed machine involved, mainly BLDC involved very precision rotor dynamics. The residual unbalanced mass can cause severe vibration and noise. That is to be restricted. The ingress protection, the hub motors, or if the motor is externally fitted in the car, it can experience the water and dust ingress, which should not damage. So the ingress protection to be tested. Suppose the machine is the vehicle or the car is coming from the hill. In case of locomotives also, it can experience overspeed, so you have to check that. The tan delta, it's the quality. This will define the quality or aging of the insulation system. Now I will elaborate it slightly. So the dimension of the induction motor is specified in IS 1231 and IS 2223. So what is IS 1231? This is for foot mounted. Means it is a horizontal machine. The machine should be like this. This is your shaft. So for this dimension, people will follow, the industry will follow IS 1231. A flange mounted motor. Say your motor is like this. Here is the shaft. So this is called vertical machine. So for that it is 2223. So the dimension will be specified. You have to restrict your dimension as per this standard. The full load test. Yesterday somebody was telling the delta connection of the stator. But for delta connection in the stator is not at all advisable for high power machine. If your power is going more than 100 kilowatt, then if there is no specific reason, nobody will design the machine for delta connection. Because for full load test, how I load it, how the shaft will be loaded, I need same one alternator whose capacity is higher than 100 kilowatt, or I have to use some mechanical load like pump fan or something, so power will be wasted. I cannot load the machine. So that's why this is star connected, and there will be in the machine there will be a neutral junction box where all the other end of the cable will be shorted. Then this test is called mixed frequency test. I'm not going in details. Okay, I'm not going to details on this. How to do? There is some transformer. You see the diagram, it is very clear. This machine is under test. You just open the terminal box and you connect in this fashion, and this supply you keep as rated of this machine, and this transformer you apply slightly low frequency. So what will happen, basically there is some short, we are going towards some short. So even though the machine is not connected, the shaft is not connected to the load, but the winding will draw the rated current. In this way we can simulate the full load test. This is another technique. So there are two power supplies are required. So in the previous slide, that was done by the transformer. So it is like this. So this it is a very interesting, and it is mathematically it can be elaborated better way, but I am not going to all these things because I am just telling you the technique so that you can know it. So this is another configuration for full load test. Even your machine, say your machine is say 5 megawatt, it's a huge power. How to load it? So that time these techniques are used. Mainly BHEL, Crompton Greaves, who are manufacturer of large electrical machine, they will be doing this kind of testing. Then momentary overload test. What is the requirement? So you have to apply 1.6 times of the rated torque for 15 seconds. This is the guideline given in IS 325. You should load the machine. 1.6 times of its rated torque for 15 seconds. Okay, and machine should not stall. Then the vibration. This is the based on the, because this is the height. This H is given in the dimension. That means that IS 1231 and IS 2223, there it will be prescribed. So based on this one, this is the vibration severity. It should be restricted on this. It is in displacement. It is in displacement in micrometer. So if you put the transducer, where the transducer, based on the machine construction, where the transducer is to be kept, all these things it will be specified in. This table is taken from IS 12075. So in this standard, where I have to put the transducer to measure the vibration and what should be the maximum limit, everything it will be specified. Ingress protection. You have to see, you may see somewhere in the motor it is written IP65. What is that? This is basically ingress protection. The first number is for dust and the second number is for water. So these are the digit. 6 means totally protected against dust. 5 means so there will be no harmful deposit, or the size of the dust should not enter inside. So, and what is maximum for second digit it is 8, means fully immersed in water also, with pressure also, the water will not enter by breaking the enclosure. It will not create any damage. So this is called the ingress protection. So this also it will be defined by the designer based on the requirement, and it will be tested. There are several dry powder is there, so that is to be flashed over the enclosure of the machine, and after that it will be opened and it will be checked whether anything entered inside or not. Then the water ingress, you have to apply the water based on these digits, which digits you have designed, and you have to check is there any water ingress enter inside the enclosure or not. Okay. The noise. So this table is taken from IS 12065, I think. So here that noise severity is specified based on the ingress protection and the RPM. So if you take the standard, you will be knowing all these things. Okay. Overspeed test. As I was telling, the machine can experience high speed during regenerative braking. So the machine should be tested for 20% extra RPM for 120 seconds for 2 minutes. Okay. Say my machine rated RPM is 1000. So I should operate the machine at 1200 RPM for 2 minutes. and after that the machine should be again checked, is there any abnormality or not, whether it can withstand or not. This is called overspeed test. Now finally coming to that test which is called tan delta. Tan delta is the test which is done on the insulation system. So normally if you see, if this is a conductor and this is a conductor and in between there is an insulator, so one capacitance will grow. There is some capacitance. Okay. So if this insulation, so this capacitance is given by epsilon A by D. Okay. It is epsilon A by D. So this is the permittivity. All these things you know. Now if I want to check the healthiness of the insulation, there is that time this tan delta it will be performed. So normally if it is very healthy and there is no aging, 100% pure, then only the capacitive current it will flow through this. That time the figure is like this. You see, only capacity, the total current is nothing but the capacitive current. But if there is some degeneration, there is some breakdown, or there is some tracking initiated through the insulator, then there is some resistive component also it will come. So the total, so if the resistive is that, so it will be like this, which is in phase with the applied voltage, but the capacitive it will lead by 90 degrees, so that's why it is leaded by 90 degree. If you take the resultant, it is the red color, and this angle is called delta. This delta will give the healthiness or the aging of the insulation system. So that's why this test also it will be performed to predict the insulation level of the machine. So this was all about today's lecture. So these things you will be, if you follow me, if you remember me when you will be working in industry, definitely you will be remembering me. So hope this is sufficient for today, and for tomorrow I will be telling. Tomorrow the class I am planning to reschedule it from morning 8 to 8:45. Again I am telling, this class will be rescheduled from tomorrow onwards, morning 8 to 8:45. Okay, I am repeating once again. For this course, all the remaining classes will be conducted every day morning 8 AM to 8:45 AM. I think today I am slightly busy also. So is there any question? Just 5 minutes, within 5 minutes we can finish it up. Will you provide the PPT slides for? Actually, these PPT slides I cannot give you. I can give the Pantech, and you can contact them to collect it. Actually, how many people I can email? That's what I'm telling. I will give the PPT. I can give the PPT to Pantech. You can collect from there. Okay, so thank you so much. Today I am slightly busy also. So tomorrow we will see. I am requesting all of you, because tomorrow slightly mathematical calculation will be involved. So exam, I don't know all these things. Submission. Okay, so tomorrow we will be slightly going for the mathematics. So I will just request all of you to just have a glance on the trigonometry, basic trigonometry, and differential equations and all that. So thank you so much. Thanks a lot for your patience.